Hello, welcome back. So in this part, we will solve example one. So in the example one, it says there is a beam of size 300 mm and for 300 mm by 450 mm. So 300 mm is the width of beam and 450 is the depth. And it is reinforced with three bars. It is reinforced with three bars of 12 mm dia as the longitudinal tensile reinforcement at a clear cover of 30 mm. The concrete used is M25 grade and the reinforcement is HYSD bar. So this HYSD bar is actually the FE415. And in this, we have to find out the moment of resistance of the beam section. So there you can see, we can simply draw the diagram. So this is the cross-sectional dimension, cross-section of the beam, and this will be the B, and this will be the D. So capital D is given here, and B value is also given here, and it says there will be three bars of 12 mm dia as the longitudinal tensile reinforcement. So these three bars will be shown here. So this actually is the beam. So this is the beam, and if we cut this cross section, say cross section XX, and longitudinal reinforcement will be shown like this in this. So this is basically the longitudinal section of the beam, and this is the section XX. So in the section XX, generally we use this section for the convenience. So this is the overall depth and this is the width of beam, and these are the bars which are given in the question. So now we have to find out the moment of resistance of this beam. So now we will follow our solution as per the steps that we have discussed in the previous part. So first step will be to find out the design constant. So in the analytical part, design constant is M and N. So we have to find out M and N. Well, we know that these M and N depends on sigma ST and sigma CVC. So first of all, we will find out the value of sigma ST and sigma CVC. Sigma ST depends on the grade of steel. Grade of steel. And grade of steel here in our question is HYSD bar or FE415. Similarly, sigma CVC depends on the grade of concrete. It depends on grade of concrete, and grade of concrete in our case is the M25. It is already mentioned in the question. It is M25. So for M25 grade, we will find out the value of sigma CVC, and for HYSD bar, we will find out the value of sigma ST from the IS code. So now I will show you the IS code. So this is the IS code. So there you can see IS 456-2000. So in this IS code, if we look at the table 21, so table 21 is about the permissible stress in concrete. Well, in case of beam, we will find out the permissible stress in terms of sigma CBC. So here you can see in the second column, it shows the value of sigma CBC. And in the first column, it shows the grade of concrete. So in our question, grade of concrete is M25. And corresponding to this, the value of sigma CBC is 8.5. So we will write 8.5 in our question. So permissible stress, that is sigma CBC, for M25 grade of concrete is 8.5. Now, similarly, we will find out the value of sigma ST. So if you go to the next page, in the next page, table 22, it is about the value of sigma ST. So in this, you can see in the the second column, it shows the tension, the tension reinforcement, which is sigma ST. So sigma ST or sigma SV. Sigma SV generally we use in case of the stirrups. We will discuss about the stirrups in the next lecture. In our case, it will be sigma ST. Sigma ST for the tension reinforcement. Now it says if the dia of bar is up to the 20 mm, in that case, for mild steel bar, it will be 140. If the dia of bar is over 20 mm, it will be 130. Well, we are not using mild steel bar in our question. In our question, we are using high yield strength bar, which is HYSD. So in the HYSD bar, this one, in the HYSD bar, the value of sigma ST is 230. 230 Newton per mm square. There you can see the new unit is given. The permissible stress will be in Newton per mm square. So the value of sigma ST from table 22 we can say is 230 for our case, because we are using HYSD bar in the question, and the value of sigma CVC will be 8.5 for M25 grade of concrete. So now we will go to the question again. So now from the table we found the value of sigma CVC and sigma ST now from the IS code. Now we will find out the value of M and N. So first the value of M. So we know that the value of M, that is modular ratio, as per IS code is 280 by 3 sigma CVC. So in this sigma CVC value we already find out from the IS code. So now putting the value, it will be 280 by 3 into 8.5, and further solving the value of M comes out as 10.98. So that this is how we find out the value of M. Now we are required to find out N. N is called neutral axis coefficient. So you may be aware of this relation. This relation I have discussed in the previous lecture. So N is equals to 1 by 1 plus sigma ST upon M into sigma CVC. So if we rearrange this formula, and after rearranging, this formula can be this one. So N is equals to M into sigma CVC upon M into sigma CVC plus sigma ST. So there you can see N is dependent on M as well as sigma CVC and sigma ST. So by putting all three values, we can find out the value of N as 0.29. So this is the design constant, which is N and M. So now we have found the design constant. Also, you can see that the AST is given in the question in terms of the number of bars. So AST will be calculated as the total cross-sectional area of the bar. So in the numerical, I mean in the diagram, you can see there are 3 bars are provided, and each 3 bars are 12 mm dia. So AST will be total area of cross section of the bars. So there are 3 bars. So we have to find out area of cross section of 1 bar, and will be multiplied by the number of bars. So in here the number of bars is 3, and area of cross section of 1 bar will be pi d square by 4. So pi by 4 into d square. So d is dia of bar. So dia of bar is given already in the question, which is 12. So 12 square. So after solving this, we can find out the value of AST as 339.29 mm square. So this is how we can find out the area of steel also. Now going to the next step. In the next step, we have to find out the effective depth. Well, effective depth directly not given in the question, so we have to work out that. So effective depth, here you can see effective depth is is measured from the center of the reinforcement to the topmost line. So this one. So D can be calculated as D minus clear cover minus half of the dia of bar. Well, clear cover is already given in the question, which is 30 mm, and half of the dia of bar will be 12 by 2, because the dia of bar is 12 mm. So half of the dia of bar will be 12 by 2. So by solving it, by putting all the values, overall depth is 450, clear cover and half of the dia of bar, D is 414. So the effective depth of the beam is 414. Now in the next step, we will find out the actual depth of neutral axis, and the relation I have already shown in the steps. So this relation we will use to find out the value of X, which is the depth of actual neutral axis, and B is already given. B is the width of beam, which is 300, and AST we have already calculated in the previous step, M already calculated, and D already calculated. So now after putting all the values, so this is how we will solve. And you can see after solving it, this equation will be obtained, which is a quadratic equation. So quadratic equation can be solved. Uh, it can be solved like for the value of x, we can find out minus b plus minus b square minus 4ac upon 2a. So in this coefficient, a is the coefficient of x, which is 1, b is the coefficient of x here, which is 24 by 84, and c is the coefficient of c is this value. So basically this is ax square plus bx plus c is equals to 0. So here a value is 1, b value is 24 by 24.84, and c is the value 10282.12. So after putting all the values in this equation, we can find out the value, two values of x. One value will be positive and the second value will be negative. Well, there is no significance of the negative value, so we will reject this value. So our value of x will be 89.74, which means the depth of actual neutral axis will be 89.74. So this is how we find out the value of x from step 3. Now moving to the step 4, we will find out the critical depth of neutral axis, which is xcr into n naught into d. So as I said, n is equals to n naught, so n will be 0.29. This is already calculated in step 1, and d is already known, so value of xcr will be 120 mm. Now in the next step, we will compare the value of x and xcr. So after comparing, we can see that the x is 89.74 and xcr is 120.09, which means x is less than xcr. So this is the case of under reinforced section, which means our beam of this question is under reinforced section. So in case of under reinforced section, moment of resistance can be calculated from the steel side. And for that, the moment of resistance formula will be this one, sigma st into ast into d minus x by 3. So all the values are known. So after putting all the values, so there you can see we have put the value of sigma st, ast, then effective depth, actual depth of neutral axis, and after solving, the value of mr is 29.97 into 10 raised to power 6 Newton mm. Or if we want to convert that in kilonewton meter, then this will be called 29.97 kilonewton meter. Kilonewton has 1000 Newton, meter has 1000 mm, so that is why 10 raised to power 6 is consumed here. So our answer, that is moment of resistance of the beam, is 29.97 kilonewton meter. So this is the solution of example 1. So in the next part, we will solve second example. Thank you.